Is this better? Okay. Should I repeat or you guys heard what I said? Heard. Okay, good. So we had our big fashion festival last year, right? And we had about 800,000 concurrent sessions. That's over close to a million concurrent sessions that we did last year. Nobody noticed. Things handled very well, but that's the kind of work that platform engineering does, right? It's and this must all be like very familiar with you. Platform engineering, they are the silent warriors, which actually make things happen. Sometimes you say, "Hey, nobody notices me," but we do. As a business, on the availability and getting to like our five nines, four nines are, they are super super important. You know. So just a little background, right? I joined Myntra about a year ago, and what brought me here um, was I was super excited about the intersection. AI is, I mean, you can't start a talk about without AI here, right? So I'm going to use, but the advancements that are going on in AI, the fashion being such an exciting, dynamic space, and e-commerce, and I just love the intersection of all three of them. And that's what brought me here to Myntra. And it's such a and why fashion, right? It's about you go through a lot of these companies have these sales. I'm my previous. If you're working in US or based companies, you must have heard Black Friday and Cyber Monday and all of that, right? And it's a once a year event where okay, there's like a peak and then there's like a big thing here. But if you look at it in the India context where we are, I mean, sale is a part of the life, right? In Myntra, we have about 4 sales a year, and these are pretty important sales. So how do you go from our normal state to a sale and then back and then again? So it's like mechanic. It's like it's not just a human process, right? We need to have these systems in place, these mechanisms in place to really scale up and scale down in like time, right? And to being able to do all of these load tests to be able to going up and coming down there. And that's why automation is really really key. And and if you look at it from a cost perspective as well, which is especially for with where how we are competing, like in the India space, especially in the India space, but it's also like globally, cost is such an important factor. While reliability is super important, it's non-negotiable and non-compromisable, but how can you do it within like the cost constraint? That's what we are really tackling on. How do we really keep our costs? And so, I mean, those are some of the things that we are, we will see more during the talk here, but things that we are tackling. And with uh, AI coming in, I mean, again, I said we can't talk without AI, but in the last 3 years, from what I'm seeing since the evolution of generative AI, and just last December, when the latest frontier models, things are like rapidly evolving, right? And we can see this transformation going on in our organization as well, where how now if you look at the software development lifecycle, we're talking about AI development lifecycle, but our requirements gathering and our development phases are really getting squeezed, and things that we're able to churn out much faster. Now, I think the questions are how can we really build, deploy, operate, maintain those cycles? How can we really take it to the how we want to really maintain that improve the velocity, right? So those are questions on top of our minds. That's what we are actually trying to solve. How are we really putting our systems in place? How are we getting our adopting the latest technologies, building the latest tech? That's what we are. And as we've made significant progress in our AI adoption, where you can talk about right now we had metrics about 70% of all of our code is actually using agents and using our things which are actually being there. And so we've seen a significant improvement in our velocity as well. How does all this now, what that means is we need to have a lot more deployments, a lot more testing in place, a lot more, how do you put rollbacks and how do you do things at a 10x scale that what we used to do, you know, and without compromising on reliability, without compromising on risk. So those are some of the things that we are tackling. You will see today what we've lined up here, talks, all going into that. But what I want to just say is like it is such a exciting time to be in this field, and you can see this, and this is the time for us to really jump on, what is happening on, how do we bring all of those advancements into SRE and taking it there. I think that's where that time here is. But I want to welcome all of you. Thank you for coming here. And, I hope you have a great session today. It's a lots of learning. And before I leave you, I just say this group here, think about it, you're building systems for 1.4 billion people in India, where people rely on these systems. And some of you, I'm sure, are building systems globally as well. But that is the impact that this group actually makes. And I want all of you to be super proud of it, and have a great day ahead. Thank you.
Thank you, Dinesh. He rightly pointed out, like, whenever we are building a system, e-commerce or whatever, which is at national scale, this is the scale which other countries, entire Europe doesn't have. Some of us work for an European company now, and we could see in our earlier days the amount of traffic that we were handling in our systems. Probably entire year we'll gather that traffic per second, per minute. People have stopped talking about per second queries these days. So it is something like that. Only e-commerce of our country most probably would be able to speak in terms of those numbers, which we had in our Yahoo days. So take pride in it and try to look. Okay, so thank you, Dinesh, once again to the first tech speaker from Myntra. At least 10 plus years, right?
Yeah, so we have been doing the sale events for at least 10 plus years. So this time we decided to do something different. Okay, and so you can see the title of the talk. I'll just maybe go into detail on what the problems were and how we solve them. And this is something very unique. It should be exciting. Yeah. So motivation. So Myntra's load testing, right? So what we call as load testing, just to set a precedent, we actually run our perf tests on our current prod environments itself. This is might be different from how other software companies work, but this is how Myntra works, and there are good reasons for that. So one main important reason is that it saves cost, right? Do you really need to have two huge perf test environments and your prod environments, right? So can we leverage our existing prod environment itself to do perf tests? But that comes with its own set of problems, right? So we have seen in the past that maybe sometimes when somebody actually does a prod load test, we have seen cases wherein there was some amount of downtime, right? Because the traffic actually interferes with your actual prod requests, right? So our goal for this MBB was to avoid production downtime, right? We also want to minimize something known as slotting, because Myntra is a microservice kind of architecture wherein we have got around 500 plus services. Each service has got its own set of dependent services, right? The way we handle dependent services is we have a dependency graph wherein there's a root service and you have services going in line all across and finally reaches your end state, which is your actual user calling service, right? How do we ensure that all these services are tested properly in the right order? Daytime load testing runs, sometimes we were doing this at night as well because we want to minimize the production impact. And of course, minimize developer burnout. We don't want to be running these load tests at odd hours. Can we do better, right? So we decided to tackle all these problems as part of this sale, and this is what we're going to talk about. This is the motivation behind the following project, right? Practical constraints. So it's quite easy to basically just set up a separate production load test cluster, right? I think that's the obvious answer, but as I said, that there's some cost. There are operational challenges because you'll have to maintain configurations, right? You'll have to have other set of configurations which might lead to maybe some kind of inconsistencies in both the prod and your test environments. And also we have got this 500 plus microservices, right? And because we run these load tests once every quarter, there are a lot of functional changes that go as well as part of your actual sale, right? So we routinely launch new features as part of a sale, right? So it's not only your perf test, we also have got actual functional tests which actually see the light of the day as part of your vertical load testing changes. So we have all these constraints there, right? And the main important constraint is fixed timelines, right? The sale is planned well in advance, right? The sale follows like the fashion festivals of India, right? So let's say we have got Diwali, we have got Christmas, right? So all these sales have got fixed timelines. We need to get all our systems up and running, vertically load tested and verified before these sales, right? And of course, we don't want variable results, right? So it's highly possible, okay, it runs on our load test environments, but just fails in actual production runs, right? That wouldn't make sense, right? So we have to tackle all these problems and finally execute as one team. We just don't want like one odd service, right, which doesn't pass. And let's say we have got 500 services, 499 of them pass and one service doesn't pass. Our test is actually a failure. We need to all move together in one common direction and ensure that each and every service is properly load tested before the sale starts. Yeah, so how do we solve this, right? We tried 3 approaches. I'll talk about all 3 approaches over here. So I'll talk about the second one, right? Dedicated pre-prod, right? I think this is a fairly common term. Dedicated pre-prod infrastructure, right? We create an isolated production-like cluster, and we have got our DNS ingress all set up. It's a complete copy of your current prod environments. And yeah, so we run the test on this environment. We have since it's a proper clone, so you have to have all your configurations cloned, right? There should be some kind of automation. There is some kind of operational overhead that also gets included as part of the second approach, and of course cost, right? So this was one possible approach that we looked at. I'll talk about the pros and cons and finally which approach we actually went with. We tried the first one, variable name endpoints. Again, it's like a very simple solve. Can we just have environment-based variables, right? So if you're calling www.xyz.myntra.com as an internal endpoint, can we have www.xyz-nfr or loadtest.myntra.com, right? Simple way to perform routing, but again, you need to have DNS clones, right? You need to set up the environment there. Most importantly, right, Myntra is a microservice architecture concept. Each service can call multiple other services, right? Especially when you are an aggregator service, you might call 10, 15, 20, 50 other services, right? Now, if you make DNS changes, there always exists a possibility that how do we ensure that the right DNS is pointed out, right? Because as part of your load testing environments, you want a service deployed on a load testing environment to call another service which is also on the same load testing environment, right? So there is obviously going to be a lot of developer effort. You might have to make some fairly risky configuration changes, which we were not confident of, right? So our goal is to minimize developer overhead and ensure that things can go completely automated. You make fewer but high quality changes. The third approach, Linkerd custom header routing. This was just an insight, right? We just came that since we use our, so our entire microservice cluster uses Linkerd service mesh, right? We are on K8s. Can we leverage Linkerd, right? So just to give you a background, so Linkerd runs as a sidecar on every pod in a cluster. So we just figured out, okay, that can Linkerd play a role as part of our load testing, right? Can we solve both problems, right? Can we ensure that minimum developer changes? Can we ensure that minimize cost? Can we ensure that we have got fewer but high quality changes? Can we ensure that configurations are not replicated, but they are just one single configuration which goes for both your perf testing as well as your current prod setup, right? Pros and cons, as I mentioned. Pros of variable name, yeah, it's fairly simple. Cons are going to be like management overhead, config debt, right? Each and every team would have to make this change. Dedicated pre-prod infrastructure, as I mentioned, cost and maintenance, definitely one of the biggest cons over here. Additional effort for all our internal DevOps teams. Some of the good parts are you can actually do your testing on this pre-prod environment much before. That was a possible pro that we looked at, but because of the cons, we didn't go with this approach as well. The final approach, Linkerd custom header routing. So if you can just look at the subtitle there, right? So Kubernetes, so we try to leverage something known as gRPC route and HTTP route, where we can define rules, right? So can we leverage these rules in order to ensure that we have a parallel load testing setup without the cons that come from the other two approaches, right? So here also there were a certain set of cons that we thought about as part of our solutioning, right? There could be a possible latency delay because your code change would have to be on the Linkerd side. Linkerd could get throttled at some point of time, especially with the load that we operate at. Right? So that was a possible risk, and this could have only been validated after running some kind of proof of concept on this environment. Application teams must ensure NFR-specific headers. This came out as a con as part of our proof of concept. But we'll just go over that how we solve this particular con, and we ensure that we didn't have a con as part of our final run. Right? So here it becomes very important that we don't mess up our current prod setup. Right? We want the benefit of exploiting common configurations across pod and your NFR or perf test environment. But at the same time, we didn't want any of our current production traffic to get impacted, right? How do we solve all these problems? We'll go over the exact approach in detail. Yeah, so Linkerd custom header routing. So the main insight is that Linkerd has got a Linkerd inbound and a Linkerd outbound call, right? Each and every service can make a call to another service, right? So these are microservices. We can make these calls either by using something like an ingress or just a internal linkerd call, right? So an example would be, let's say we have got something known as gateway.myntra.com, which is our first endpoint. Gateway.myntra.com might aggregate data from a bunch of other microservices. So we have got, let's say, your actual list page calls, you have got your pricing calls, you have got coupon calls, you have got your serviceability calls, right? All these calls, we actually don't have to make these changes as part of code changes, but can we have some kind of auto-attach header mechanism so that all your linkerd calls, so your linkerd basically deals with the routing on its own, right? This was the insight. With this change, teams didn't have to make a single line of code change, right? 500 plus services, all 500 plus services didn't have to make any code change. All we had to do was automate your deployment on the separate NFR cluster, and that's about it, right? You just start off with your load testing, and this is completely decoupled from your existing prod clusters, right? So NFR applications, so NFR/VLT or load test or perf test, it's all the same thing over here. So our load test application would be deployed in a separate namespace with something known as -NFR, right? So if you have got a particular service, let's say gateway.myntra.com, it would have something like gateway-nfr.myntra.com. Internally, we would have a separate namespace as part of linkerd, which would also route to this particular NFR namespace, right? But there's a huge problem over here. We didn't have any out-of-the-box solution as part of linkerd, right? Linkerd has got something known as HTTP header-based routing, which is just for inbound calls, right? Now, I'll give you a simple example, right? Let's say I am a prod service and I get this NFR header, right? So the header can be something like NFR is equal to true. So NFR true, I get it, right? Now I get it, and I currently am in the NFR environment. Now, as part of my microservice code, right, the actual application code which runs over here, that code might make a call of its own, right? Now, I get this request, I might do some kind of processing and call, let's say, a bunch of 10 other services, right? Now, this 10 other services, I'm going to explicitly put the name of the linkerd namespace, right? So something.svc local, something of that sort, right? When I make that call, right, because it's a own custom call, this particular header is not going to flow, right? So basically, there was no out-of-the-box solution, at least we didn't find any, which would actually transfer these headers without any code change, right? Because this would just stop once the first NFR request comes, right? It just gets cut off because your subsequent calls would not actually go to NFR and would fall back to your production environment itself, right? So it became very important for us to transfer our NFR header from linkerd NFR to other linkerd NFR without any code change, right? So how do we do it, right? Why not we upgrade linkerd and make the code changes ourselves, right? Linkerd code is open source, right? We are using our own linkerd image. Can we go and take the linkerd fork? Can we have our own custom version of linkerd, right? Can we, because once we have got linkerd's code, right, and once we deployed internally on our NFR clusters, right, we have got complete control on how the routing is going to work, right? So this was the insight, right? And how do we, so if you can just look at this diagram, right? I'm not sure it's, yeah, so our first call, so if you can see the first box, right? The first blue box on the left, there's something known as Scale It. Scale It is our internal load testing framework. So the only job of Scale It is to go and fire requests at very large scale to simulate production traffic, right? Scale It runs, so Scale It is going to hit the first the first call of your internal Myntra framework. It can either be the first global call, so global I mean is the first public call that comes into Myntra, or it can be the first internal service call, right? So we have got two concepts. We have something known as a vertical load test, which is just testing your internal service in and of itself. And we have got something known as horizontal load test, which is basically try to replicate your actual production traffic coming from the Myntra app or the website, right? Either way, the first call comes from Scale It and reaches Myntra's internal systems, right? So if you can see, yeah, sure. Yes. Yeah, it's already full screen actually. Yeah, sure. Yeah, so I'll just explain these, yeah, these boxes, right? So if you can see that there's a service A pod, there's a service B pod. Each of these would have their own sets of NFR pod as well as your prod pod, right? So if you can just see over here, right? So the main concept is that once something enters into production, it stays in production. Once something enters into NFR, it can either go to an NFR if the header is present, or it can go to your current production if the header is not present, right? So this is the basic rule that we're trying to follow over here. So what this actually means is that if all your services are onboarded onto your NFR environment, then your header should flow in such a way that all your requests, right, without any code change, is going to flow into your NFR pods itself, right? So this change was only possible by actually making a separate Linkerd deployment, right, with our own custom image, and having your applications deploy on this separate Linkerd NFR environment, right? So with this, there was no code change. Now the first obvious question, right, would be that, okay, that how does this routing work? Is there going to be any performance impact for this particular routing? Because finally, it's a code change that we made as part of our own custom Linkerd image, right? So as part of this code change, okay, yeah, that actually is the code going to be performant enough? Do we have any places where there could be some kinds of latency issues, right? It's not just that the first hop, right? So your Linkerd routing, the way it works is it first goes to your production pod Linkerd, and then from there the routing rule kicks in as part of your Linkerd control plane, gets the route, and then switches onto your NFR pods, right? So as part of this, so there's a small extra hop within the same cluster, but still, like, the obvious question is that does it have any performance impact, right? So the answer to all these questions is no, it didn't have any performance impact. This actually went live and we had a fantastic sale. There were no actual latencies issues, right? I'll talk about some of the actual challenges that we faced in actually getting these live and up and running. Yeah. So I'll talk about some of the scenarios that we tested, right? Request from outside of Myntra to first HA proxy service. Okay. So for perf test, so from your scale it, right? So scale it is our internal load testing environment. From scale it, for making a request into the entry point, we had to explicitly add this header, right? The header is something, is just a normal NFR is equal to true, right? So now with this NFR equal to true, without any code change, each and every microservice is going to forward this particular header, and because of the Linkerd based routing rules, we are going to see that that the exact pods, right, were always NFR, and we never had to fall back to the actual prod pods, right? So this made it completely safe to handle. Request from internal service A to internal service B ingress, and request from internal service A to B via the Linkerd, right? For both HTTP and for gRPC endpoints, right? So with the NFR header, it always goes to the request, goes to the corresponding NFR instance, and without NFR header, it should go to the prod instance, right? So based on these header-based routings, we are able to solve this problem for internal service calls. One thing that we did not take into account, at least as part of this iteration, is we still continued to remain stateful, and that would mean that our production instances of your database, caches, queues, right? All of these were common, right? This we would be picking up as part of a later release, but as part of this, we just ensured that our production pods and our requests were completely independent of the other, right? Which means that no request from production as well as NFR got combined as part of these runs. And a dependent service does not have a corresponding NFR setup, so all these service setups were completely handled in an automated fashion. Right, so the entire deployment, all these things, right? It just takes a copy of your current prod configs and just makes a clone and then deploys it onto your NFR setup, right? Yeah. So implementing changes, so I'll just talk about all the challenges that we faced, right? There were a bunch of challenges. This was not an easy project to implement, right? From figuring out that how to actually model this entire, entire concept, to get all the teams onboarded, right? We didn't want teams to actually have any pain points in implementing this, and we needed to actually leverage the benefits of having a parallel infra for a load testing, right? So Linkerd does not support annotation-based header patching for outgoing calls. So what we did, we forked Linkerd, made code changes, and created a custom Myntra Linkerd image. I'll go over the code for this as well. Linkerd images require release builds for the best performance, right? At least we didn't have the required know-how to actually make the changes for this code. And guess what? We used AI, right? Claude wrote the code for us, right? So the way Linkerd works is it runs completely on Rust. You need to have your cargo build set up, and Claude helped us make these changes. And the main point is that in the first run, we actually tried with a debug build because we had a smaller release server, right? So our build server was quite small. So we could only do our debug build because these builds take a lot of time, right? It takes around 15 to 30 minutes for a proper release build. So what we did was we got a custom machine, which was like a single 32 core 120 GB machine. It took around 30 minutes and we got the build running. This was a proper release production ready build. Ensure that all individual services add explicit NFR code in their load testing scripts, right? So now as part of vertical load testing, as I mentioned before, each and every service would have to independently test their API endpoints and their services. So how do we do that? We didn't want teams to make even that particular change, right? So if I am the owner of, let's say, a pricing service, now pricing service has to be independently vertically load tested. So I might have to put a header there, right? Now we have got like at least 1,000 API endpoints. We have got, let's say, 500 plus services. How do we make the change across? Again, we were able to make the changes in a single place as part of our Scale It repository. Go and deploy these changes, and each and every API endpoint and every service load test had these NFR changes baked in. So we made a blanket code change over here. The need for any pre-service code change was not at all required. Manual setup was not at all required. We auto-created all the NFR namespaces with the correct Linkerd proxy annotations, and that was it, right? So we got our entire namespace for NFR up and running. One important thing is that because as part of our sales, right, our sales run for a short duration for, let's say, 1-2 weeks. So as part of that 1-2 weeks, we wanted this particular load test environment to run only for the particular duration of the load test, right? Because your final load will go into your prod service itself, but as part of load test, we are going to just make a copy of all the infra, right? Do we really need to keep all that pods and all the costs for that infra up and running for an extended period of time? No. So what we did was we made sure that once the load test was completed, and the load test took around like 2 to 3 days, right? So as part of 2 to 3 days, we finished the load test, and then we just shut down the entire infra setup for this VLT environment, and that was it, right? So we saved a lot of cost on this particular cleanup process. Yeah. So I'll just go over the code change, right? So I've just taken a video of the PR. I'm not sure. So it's a fairly standard. So this is the actual Linkerd proxy code. So as part of this, so you can see that we have something known as Myntra NFR header, which is nothing but Myntra-NFR-test. Right? So we just pass this header. You can maybe just go over this video. This is the complete PR which was raised. And this is open source, right? So our goal is to maybe try to get support from the Linkerd community and get this merged as a proper out-of-the-box config, right? So you can just take a look. All of these are just test cases. But the main point is that as part of your outgoing request, can we just patch this particular header, force that header into every outgoing request call, right? That is basically it. And this would also mean that we have got two separate versions of Linkerd running. So one is on our NFR test environment and one is on our prod environments, right? Both the Linkerds have been cloned from the same version, so which is 1.18 or something along those lines. So we've taken the fork, made those code changes, deployed on this NFR environment, right? It's fairly straightforward code. Yeah. So finally, what was the end result, right? VLT results. So we had around 70 plus services taking part in this event, like who are ready to actually be onboarded. So 70 via NFR. Total was around 150 services, which had both NFR and prod. Some services actually were not required to be part of this, but then total, and it took like 3 days of certification, right? Minimal downtime. We didn't have any real downtime over here. We didn't waste any extra cost. This was just for the load testing. We spawned up all the machines and then we brought them down after a few days of time. Yeah. Feedback received from teams, right? Myntra is very team first and dev first. We wanted to know if the teams actually like this, right? Because this is a fairly different way of operating as compared to our previous approaches. Did the team actually support us, right? So we have got like 150 plus services there, right? So each and every team owner, the architect leads, if they don't buy in, it becomes difficult to go ahead with this project in the future iterations. These are actual real feedbacks. Thank you for enabling this. It seemed like it really helped the developers, right? So people were more confident of running on this isolated environment. Configs were same, but we had the benefit of actually decoupling our production and our load test runs. Fantastic work. Teams can run it peacefully without any production impact, right? So it gave us a lot of confidence in going forward with this approach. We were able to satisfy everybody's wishes, right? We didn't really see any setback as part of this. So we have got our next steps, which is the next big sale coming in the month of June, which is our end of reason sale, June 2026. Things that we are looking to incorporate, Kafka asynchronous flows, since we work on a Linkerd-based route, right? How do we solve asynchronous communication, right? Kafka is just going to push the event and we're supposed to consume it. It just bypasses this, right? Can we solve for this? We have some ideas in mind, and this is something that we're going to look to implement. Database caches, again, right now our entire stateful services are all common across prod and our Lotus environments. It makes things simple for us because we don't have to replicate data and things of that nature. We are able to have the common set of data. But again, right, there is always a risk of combining your database caches as part of both your NFR and prod environments. And of course, right, support from the Linkerd community to merge this feature. We feel that this is something very novel. We are looking to get this merged. So it offers two benefits. So if other folks can actually leverage this, it's well and good for us. And the second thing is we want to have a common version of Linkerd across both our prod and test environments. Right now, it's a separate fork. Can we actually get this merged so that we have got a common setup and it just makes things seamless for us? Right? Yeah. Thank you. Any questions? Happy to answer them. Yes. So the question is that can we look at the code base? Yes. Yes, please. Oh, yeah. Yeah. Yes. I'll just. These are all tests. 1 minute. Yes. 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 Yes.
How do you differentiate this is for production versus this is for your NFR?
Yeah, so we don't do that. So there are two changes over here, right? So this is the actual core change. This is the force patch because we are having two separate images, right? This is not the same image that we have as part of prod, right? The place where we make, I don't have the exact code changes for that. We use HTTP and gRPC based routing, right? So as part of the route, if we get so if we get an incoming header which says that NFR is equal to true, we route to NFR namespace, else route to prod. So these two changes. So here it's an like a force patch, right? This image is not the same image that we have in prod. Yeah. Yeah. Want to show that? Yeah.
So am I audible here? Yes. So according to your question, how the routing in production and NFR actually works. So when we see this layer here, right? So at the ingress layer, we've created an ingress for both the NFR environment and the prod environment. So the rule for routing to both an NFR backend and a production backend is set in our HA proxies, correct? So what happens here is now we've added a condition here, route ACL, which tells us if the Myntra NFR header is coming, then route it to the NFR backend or route it to the production backend. So that is the north-south or the external to the cluster routing. Now, if we look at the Linkerd to Linkerd routing, which is the service A to service B routing, what we have here is so once this the ingress has got the NFR header, now the service has got the NFR header and an ingress for both the same host name but different backends still exist in the HA proxy. So what happens now is, so the request got into the service A, now it has to send out to the other services. So our Linkerd patch here, it assigns the header automatically in the subsequent service calls. There, when it hits the other linkerd of the service B, there we have a HTTP route policy or a gRPC route policy setup, which tells us, okay, it has come with the same host name, but it has a Myntra header, which is defined, the NFR header, which is defined there. So what it does is, it tells it that, okay, because of this HTTP route policy, route it to the NFR backend rather than the your production backend. So that is how we are routing it. Correct. Correct. So rather than us sending the headers again and again, Linkerd pushes the headers with it. Correct.
Yeah, so the routing changes are as part of your control plane. So the gRPC route, right, you'll have to have that logic written there, which is nothing but an HTTP route that for an incoming header, go and route to an NFR backend, else route it to your normal prod backend. Yeah. See, but yeah, so that's an important point. As I showed in the previous, like in the next slides, right? So not all of our 150 plus services were part of this particular VLT process, right? Like there could be cases wherein we have got a dependent service which doesn't want to be part of this NFR testing, right? So for them, if you don't even configure a new NFR backend, right? Even if I get the headers, right? Those calls should just request back into production itself, right? So a simple example can be something like a switch, right? Like a remote config kind of service, right? Now, remote config services are very light services, and you really don't need to vertically load test them or like keep them really as a specific NFR test environment, right? So can we just exclude those services from this entire load testing process? So we don't configure the backend for them at all, right? So in those cases, even if I get the NFR header, it should just go into production and not to NFR because NFR doesn't exist for that particular service in the first place.
I'm audible. Hello. Okay, perfect. So what it does is basically, so Linkerd has passed another request with the same header, with the same service endpoint, everything, because there has been no code changes. So it thinks that it has to go to production. The only addition is that the NFR header has been added. So the only thing that HTTP route does here, that okay, the production pod has received this, the request has come to production, but it has to route it back to NFR. The HTTP route specifies that, okay, you've come with this header, let's go to the NFR backend. That is so gRPC and the HTTP route, they route it with the liquidity request to the NFR backend. Correct? Correct? Correct. Perfect.
For all the backend APIs, right? So starts from the first call, which is going to be api.myntra.com, which is our gateway layer. So everything from that onwards, right? It's purely backend, right? So we have got a bunch of services over here, mostly Golang Java-based services.
I have one question. So I think this is really out of box thinking where you are doing a performance testing on production. It's a very good insight for me. What I wanted to understand is the database and caches are still same, right? So how you are reducing that invalidation of caches or database getting slow response? So how you are managing that particular part?
Oh yeah, yeah. So the question is that how do we tackle database caches, queues as well also, right? So when we actually get prod traffic, we don't have a proper solve for this. The way we do it is that we just scale up well in advance in the case of prod, right? So since our database caches are common, right, we just make sure that we are scaled up for sale well in advance, right? So what that would mean is, so let's say if I need, let's say 1 core in normal prod setup, right, and as part of sale, let's say I need another 4 more, right? So it just makes it 5, right? So what we do, we just set up 5 in advance, right? Because the sum of both the requests is going to be what we expect in sale, right? So as part of our stateful services, database caches, we just scale it up well in advance in the case of production itself, and it's just going to be common for both your load testing as well as your production setup. Yes, but our goal is to problem solve and figure out a way to solve this as well. Can we do better? That's something that we are still thinking about. Yeah.
One follow-up question. So you have data created already, right? So how do you delete it, archive, right? So that the cache is not bloated and even the database indexes, everything is.
Yeah. So this is not specific to our NFR setup. These things are already there for us. Maybe we can just discuss it offline, right? Yeah, but the point is that we have the entire setup wherein we create these like this test data, and we have got a cleanup process. All those things, like there's a proper system for that. That is independent of this actual load testing environment as such. That is going to stay whether we had this environment or not, right? So we create a bunch of sample users, right? Clean up the data, right? How can you cancel orders? Things of that nature. Yeah.
Slightly a non-technical question, right? Given the amount of changes that you had to do, why not just spend the time on creating an automated NFR spin up and spin down environment?
Yeah, so this is already existing. So you can just check this slide, right? Yeah, so the need for so auto create the NFR namespace with correct Linkerd proxy and clone the latest prod config and deploys. This is automated currently.
What I meant is, why not deploy a complete parallel environment in itself?
So you mean creating a pre-prod kind of setup? Yeah. So we had some challenges there, right? So it's one of the first few things that we evaluated. First is the main cost, right? Because you'll have to just set up an entire clone of the entire environment, right? It's not just your pods as such. You'll have to have everything cloned up. You'll have to have a new cluster, new Linkerd control plane, right? There is significant amount of overhead. So I agree that there are some pros to this, right? But we just felt that it was actually simpler and more cost effective to just use it via the Linkerd code changes. And to be honest, the actual code changes were very minimal, right? The entire thing was automated, and we just had to make one change as part of the Linkerd routing logic and nowhere else, right? It's not just the SRE's code changes, but also dependent teams code changes, right? Here we will have to have a separate deployment, right? So you just give the handover to the actual dev teams for them to deploy it, right? We'll have to ensure that the configurations are replicated properly across these two clusters, right? So we felt that there was a significant overhead, both in terms of cost as well as in operations, right? So this is why we figured out that can we leverage the same cluster, right? We have not created a new cluster over here. Can we leverage the same cluster? Can we have the same set of basic configs, right? It's just that the NFR namespace is something that we had to clone, and the rest of the things did not have any actual manual overhead on the dev teams. Yeah. Yes, please.
So in your initial slides, you had said you do a daytime load testing. Is there any reason why you do a daytime testing or not more of a cron job type of like nighttime testing?
Okay. So daytime is basically our goal. We do it at night. This is because, as I mentioned, right, there are some practical constraints that we work with. Because, as I mentioned, sometimes, since we have 4 sales per year, right, these things need significant amount of developer involvement, because most of these features, right, like there are plenty of features which we just roll out as part of just for the sale. Right now, there could be cases wherein, yeah, you do your load testing and something breaks. Right now, how do you solve for that? Right? How do you ensure that we don't make any mistake when the request spill over? Right? Like there could be cases wherein the request spill over from your testing environment onto your prod environment. Right? That could cause downtime. Right? So we have teams actually working and monitoring these test runs. We keep it time bounded, right? So we have got like 2 to 3 days wherein we get this done. We prefer to do it at night just to be extra sure that we don't affect any production traffic, since we are like an e-commerce site, right? So as part of our normal so-called business as usual timelines, it's mostly during the peak day hours. Nighttime, the traffic is significantly lower than what it is in the morning. So we try to leverage our entire load testing during night times, which is something that we want to get away with, right? We were doing that because we felt that, that could be impact on our current prod traffic. So our goal is to eventually move to like a daytime wherein teams can just run it, and it just takes away a bunch of the manual, cognitive overload, right? We don't want teams to be spending night outs. So our goal is to do it in the morning during our normal BAU hours itself. Right, so that's our goal, and this is one way of reaching to that goal. Yeah. Oh, okay, great question. So thoughts on how do we solve Kafka? So we have got an internal wrapper on top of Kafka itself, which is another service, right? So this is just a thought. We have not evaluated it in detail, but it's something that I was thinking about. So now what happens is we will eventually have to have a new cluster for Kafka. That's for sure. How do we ensure that without teams making any code changes, can we toggle this cluster based on NFR and your production clusters, right? The way we do that is we currently have an internal wrapper on top of Kafka that actually returns your Kafka cluster as an output, right? And that is the normal HTTP endpoint. Now this particular HTTP endpoint gets invoked whenever your new service starts up, right? So whenever your service starts up, it calls another wrapper service, which will say that, okay, whether do I connect to this particular cluster A or cluster B? Right? Now this cluster A, cluster B again is dependent on what logic is sitting on top of that wrapper service. Now, how does that wrapper service get to know whether you need A or B? It depends on where the request is coming from, right? Whether it's coming from NFR pod or if it's coming from a normal production pod, right? Now, NFR pod, with this Linkerd-based approach, we know that any HTTP or gRPC request will obviously pass the header through, right? So this would mean that our wrapper service, right, which is a wrapper on top of Kafka, also gets to know the context of this header, right? So it's just a simple logic change, right? If I get the header as X, go and spawn up cluster A, right? Else you spawn up cluster B, right? And this just comes as the output. So your actual consumers would know that which particular Kafka cluster to think about. This is one of the approaches that we have in mind right now. Sure. Yeah, sure. Thank you very much. Happy to take questions offline. Thank you, Vasuman. So he's the rock star behind implementing all of these. Yeah, so kudos to everyone as part of the team who are involved in this feature. Thank you everyone for your time.
So thanks to Suraj and Vasuman. So one of the things, since Dinesh is still sitting here, is this must go as a merge request to the upstream. And if it doesn't go, somehow some politics come in between it and the merge request is not accepted, probably you can think of forking something and going to public. Okay, thanks for a deeper thought. And I think everybody understood by now. The way Suraj and Vasuman were explaining things and going to the deep of it, they are deep into the code. So you don't have to go anywhere to understand that who has done and who is presenting all those things. So I'm pretty much sure Dinesh will be supporting you while you make these things. See, we do a lot of things. The problem with us is we lose on the tenacity to publish it upstream. Okay, so I hope that you understood the importance by now and you should make it this PR go. And use our Discord channel. These folks know the LSP Discord channel to have your voice so that people look around it, you get a wider community support in favor of your PR. Thank you, Srix. Our next speaker, now we are shifting gear to AI. Okay, please. You connected to the meeting, right?
Thank you, Devanshu. Give me a minute to set it up, actually.
Sure.
Check. Hi, everyone. I'm Sirix. Um, I'll make a small introduction. I know that I am between you and your lunch, but bear with me. This should not take much. A few slides and an interaction session. Um, First of all, thanks for this very insightful talk, Suraj and team. It's very impressive to see the scale they've achieved and how, to know that in first-hand experience, like how it was done. It's a great work. And especially, sir, for you, my kudos to you for real-time reviewing the code, pointing out which line it is. That was a great demonstration of skill. Okay. Okay, small intro about me. I started my career working with enterprises like Motorola, Tektronix, building gigascale networks. Later, I started my own startup where we invented a new technology in networks communication. We still hold the global patent for it. A lot of companies have licensed it. Then I went on to found two startups. Then I have been as a fractional CTO for a couple of them. So in the past, I have built 7 teams from 0 to 1, and some of them went to raise like a 50 million Series B round, all that. My understanding of building team has radically changed after AI came in. So this whole session is about who builds the new infrastructure. Where is the role of a developer? Where is the role of an agent? So that's the lens I'm going to use. There are some frameworks, there are some techniques. Hope some of them will be useful for this audience. Okay, so before I go there, I just want to show of hands. How many of your teams have adopted AI? Show of hands, please. Pretty much. I'm sure who are not raising their hands is like, they're too hungry for lunch. Yes, I can see 95% of people raise their hands. Now, follow-up question. How many of your team you think, because of AI, have become 10x? Brilliant. That's still a good number. I can see 25% of the number. Excellent. So 10x is the North Star guiding metrics when you do AI adoption. Whichever metric you choose to, but that's the line. And many teams are not yet there. We'll see why. Okay. What I do now, I am the founder of AI Native Orgs, where we work with CTOs and CEOs to redesign their internal engineering process to achieve this 10x shift. And most of the times, I'm going to share one question that almost always asked by CEOs and CTOs. And the question goes like this. How do I know my team is using AI fully? So fully is being the qualifier. Now, almost all the teams are using AI. As a developer, we are all using AI. But how do you know you are using it fully? If you don't use it fully, how do you know what is the opportunity cost? So this is a single most top level leadership question that your organization faces at this point. Your team lead, you will be facing, your team leaders will be facing, your engineering manager is having this, and it escalates to the top level. Now, really? Sorry. Maybe restart. Okay. Yeah, it's a separate tab. Here. No, I'm trying to see this one itself, right? This is the one. For that. Sorry about that. Okay, so this appears to be the topmost question of the industry right now. Is my team, my organization using AI fully? Most organizations do use, I'm representing this at the top of the iceberg, but there is a huge opportunity cost of not leveraging that. Now, this is another angle to look at it. Your team, doesn't matter as a startup, doesn't matter as an enterprise, the high impact AI adoption is still in single digit. And sometimes AI really delivers, but how do you get it consistently? How do you get all the time across all the teams, across all the organizations? And if you don't, you're going to miss a big boom that is happening, right? So here's a small insight. So most projects at the infra level or at the product level goes through these bell curves. The majority of the time and the investment goes in building the tech, right? What to build, how to scale is still a complex problem, but it never took as much, it was never a cost center as much as your tech. But when AI done well, the cost of building or the investment in tech has dramatically collapsed. And now what it opens up is you can reclaim the resources back to discovery or back to scaling. So if the teams are not using AI fully, the latest techniques, the right models, the right SDLC process, the AI-centric way of designing the product, you're gonna lose this leverage over your competition or to other teams. Go for it. You can reclaim the resource, yes. Go for it. Mm, mm, mm.
I'm going to save cost here. Why do I not go down all the way and ensure that my stack is stable and steady enough before I shift it to the other things? That is possibly done better by people who are well versed in other activities. GTM is more of a management functionality. You don't need engineers to do GTM. If you ask engineers to do GTM, they will do shit out of it. Same thing at the other end. Engineers are good at doing engineering, and we have to appreciate that. So AI is good at helping them ensure that their cuts happen fair, but then there is a top bottom stack that is full of crap, which basically ensures that you're wasting resources just because you have not leaned them, meaned them, you have not ensured that you are working optimally. Why don't we use our resources there?
Absolutely, we should use. I'm not arguing a case against it. But I have a different point of view on engineers being in GTM. I'll come to that. But yes, so this leverage only happens when you go back, attend your technical debt. When you go back, you modernize the previous stack. When you go back, you redo the UI, UX, all that, right? But you can collapse the cycle of these shifts with AI. So I'm with you on that. I'm a little bit having a different opinion around GTM and engineers. We'll come to that, but that's not very important. Now, this is one of the main slides when I talk to a CTO or CEO of a large organization. Instead of me telling them where they are, I allow them to do a self-assessment. Pretty much they'll spend 3 to 4 minutes deliberating with their top leaders where they are here. It's a self-assessment slide. I would like you to look at this and assess where your team is in this paradigm. So largely these are the paradigms currently, at least as of today. Heard about these three. They are more academic. Maybe Anthropics will work on this or OpenAI will work on this. But look at till 5 or 6 this side. Can you do a self-assessment? And I want to look at how many of you think you are in the first 3. How many of you do you think you are in the second 3? Let's look at the first 3 show of hands. Fair enough. Let's look at second 3 show of hands. Wow. This is a creme de la creme of Bangalore's, skill in enterprise. So I'm not surprised. There's a fair distribution around this thing, right? Now, this is the breakthrough shift for the current industry. If you think your team is here, if you think your org is here, and if you think you're consistently doing at this level, this paradigm, then you are leveraging AI fully. This is one way to look at it. And I will encourage you to move forward like this, as fast as possible. But this is good enough. This will be good enough for this year. The only question is, if you are here trying to move here, if you are here trying to move here, and how to move and what is the challenges in moving, those are worth solving with engineers. Coming back to, sir, your point, right? So this is the major observation. Some of you might know, but not have articulated this. So where the industry is right now is there are greenfield projects. Greenfield projects is what you see in all the hyped video in YouTube, those blogs, those Twitters, where the code is written right from the first line by AI. AI chooses the right stack, right architecture, make sure that architecture is documented, make sure that code is tested. All this happens almost at zero cost. The cost is actually in planning, deliberating more planning, and then cost of tokens. Now, large organizations, enterprises, do not make money through greenfield projects. These could be internal tools. These could be some optimizations, test infrastructures. But enterprises' core critical infrastructure is classified as a brownfield project, where you already have a code. You've made a technical decisions, your foundations, your stacks, all this have been, there is trade-offs, right? All this time we have been operating in trade-off. I have a very good TypeScript team. How can I reuse? Oh, I have a deadline in 3 months. How can I repurpose my team? So there are trade-offs. Because of that, we have chosen certain stacks, certain architectures, certain implementation, and there's a technical debt. When brownfield projects, typically AI is introduced in this, there are a lot of challenges. And these challenges are not often discussed in these hyped articles. So they are very internal to enterprise organizations, and enterprise organizations has to learn through the peers, and these techniques still are emerging. These techniques are still getting refined. And that is where the resources, I think, should be diverted. Okay, so the framework is what? I've tried to simplify. The framework is this. When you are building AI native products, this is not like slapping a chatbot or some RAG on top of an existing product. A product reimagined in AI will look way different. I'm putting a case, AI native products can only be built by AI native teams. AI native teams can only be comprised of AI native individuals. Now, what is AI native individual? A simple definition, my interpretation is this: solve your life's problem with AI. Okay, I went for an event, today's event, there were some 500 photos. What I choose to put it in LinkedIn, use an AI to select it, right? Else you're gonna spend like 2 hours in selecting it. Hey, I am reading 5 articles on YouTube. I want to consolidate and see which was more useful to me. Use some transcription service, use some summary service. If you are not solving your life's problem with AI, you will not walk into a team and say that, how can we make this infrastructure faster with the AI? So the redesigning with the AI being centered will not be native. So encourage people to be AI native individuals, and they become AI native teams. And then when the teams see the advantage of using AI in the infrastructure, in the building, in the agents, they empathize. If I'm seeing the benefit, my customer also should see the benefit in what value we are delivering. So the way the team builds the product radically shifts if this is the way it's structured. Second thing, so as a developers, right? We are all proud developers. I come from I still write code. I still part of open source projects. I make architecture decisions. I'm proud of it. But I know I will not be recognized for being a developer. This is a controversial statement, but I have to make it here. Be the orchestrator. An orchestrator is the one who gets the outcome done with AI. A developer is the one who gets the code written with AI, with whatever technique you use. be the orchestrator. An orchestrator knows how to manage agents, how to unblock agents. Now, as in the next few slides, we'll see that the artifact of a team is shifting from code to agents. Agents build your infrastructure. Agents generate your code. Agent generates your test. As a developer, we are just, we are shifting to a powerful place where our role is to unblock the agents. So this is how new AI native teams are getting constructed. Yeah, see AI as an engineering leverage, not just the speed. Okay, so I'm not going through all the list. I think the first couple of them applies to engineers here. Our role as engineers has shifted. This is impacting the way we hire, way we appraise, engineers, the way we're gonna, build teams, the size of the teams, the cost of the investment into tech teams, engineering budget, everything is radically shifting in 2026. And this is the underlying dynamics. Engineers don't write code anymore. So your super skill is getting challenged. Code getting reviewed and generated in real time by AI. We as an engineer are delegated to reviewing the code and unblocking the SDLC process. Now, this is another slide. Before I go to the agentic slide, I want to share this. What is the role of a system architect? What is the role of a developer or an infrastructure engineer? Earlier, a developer writes a code. Earlier, a system architect designs the system architecture, block diagrams, sequence diagrams, protocols, API definitions, so on. But now the roles have shifted. Code is generated. If you're writing a code, I would like to request you to rethink what is missing here. Code should be generated. However, context has become the single artifact of an engineer now. How do you make sure a large context like an enterprise projects usually have is stored, updated, retrieved in real time? So the engineering work around context is the new puzzle to be solved, and engineers' role is shifting there. Not only the engineers, the responsibility of many other teams is also to keep the context updated. So context is the single most output of a tech organization, not the code. Code is a generated, disposable artifact, which is a side effect of the context. So system architect's role has been shifted to context architecture. Because with the right context, AI can always generate the right system architecture, or it can do a better job. So the idea is we need to realize no more organizations' output is lines of code, or the critical artifact is not code. The critical artifact is context. I'll rush through this. Most of you might know this, but in case if you're not, I want to put this picture in your mind. Your context is supposed to reside inside your own project. The best way to do is a spec-based development. That's the easiest and single most high-impact way of capturing the context inside your project. Check in all your PRDs as specs inside your project. All requirements in some way, either if you're using Jira, if you're using any other tool, it's fine. Write an agent that picks up whenever it gets updated and checks into the local project. So you have the context in the most native language an LLM understands, right in the project itself. What is that? That's an example. It's an ideal customer profile. This is I think, the software example for a marketing function. This is what I was talking about. So I want to take little diverge from that to address that point. Engineers are building infrastructure that can be used by product managers to build the product. So pay attention to the statement. You are building the lovable for your enterprise, not the product. You build the agents which which allow the product managers to build and generate the code and then deploy the final product. This is the new architecture paradigm emerging. So once you do this, you build agents that is going to enable your GTM. You build agents that is going to enable your sales team. You build agents that is going to enable your marketing team. So that is where the world is going. So engineer's job is to enable this agentic layer across all functions rather than building the end product. It's a bold and controversial statement, but I want to leave that in your mind because you will connect the dots whenever it's ready. Yeah, so the reason for this example is, yeah, you have the spec and all your agents also stays inside your own project. So you have more context. And pretty much right-hand side, what you see is a new artifact, right? These are English statements. So you are no more bound to any particular learning curve of a stack or a format or a language. This is what I'm trying to communicate. Humans, I mean, all of us here, the developers and engineers and testers, whatever you call them, they are going to create the context, whatever way to engineer this. This is not simple as you think, not those examples I showed, the spec file and all that, right? Enterprises, the context is huge. Sometimes it runs in gigabits of data. So how many times you have to abstract to get RAG-ready access, that itself is a complex architecture and it's not simple. The techniques are still refined and getting evolving. So as an engineer, you build the context layer. As an engineer, you build the agentic architectures. There is no need to think agents as relegated to only few functions. The lens to adopt is the whole product should be generated by agent. Am I ready or not? How far I am from? Let's architect towards that. So agents uses this context, and then they start generating your product or the infrastructure. Now, if they also take care of updating the context. So that's why it's a loop. Agents, so you build your agents in such a way that they can access your context, they can update your context. So its context is recent and alive. And they generate the app. Earlier paradigm, humans generate the app. But the new paradigm is agents generate the app. Right. So my recommendation is on day one, when you're doing AI transition or when you're declaring my team is adopting AI, I think the first step to do is set up some basic infrastructure to track AI metrics. This is a dense information about what you can do with AI, what are the AI metrics you can track. But I'll say start with some DORA metrics, start with some RACA metrics. You adopt at least 1 or 2 metrics to begin with and then build on top of it, but measure where AI's contribution is happening in your team. That is very critical. Right. So I'm going to run through other few numbers. So yeah, this is, this I want to talk about. Most AI native projects, when they adopt AI, they see that in the first sprint or second sprint, there's a huge improvement. But there is an impact of that. If you're not measuring AI's impact, if you're measuring only on the positive impact of AI, how many lines of code I added, how many PRs I committed, that is not sufficient. You also need to understand what are the side effects. So your metrics should be real, and it also needs to understand the negative impacts of AI on your project. Yes. So measuring what matters. Define that AI, the measurement layer right in the beginning of the project. These are some examples that I'm giving. So it applies, pick and choose what applies to your team. Right. So this is critical. You saw the paradigm 4, which is what currently the industry is looking at. And the critical part, missing part is this. So any AI adoption starts with this ladder. Here is where many people get stuck, especially at the enterprise level. Startups can jump this. Small companies can jump here because their projects are disposable. They can always re-implement in a new stack, or they can rebuild it. But enterprise, because of the risk in any modernization projects, because of the risk in building those infrastructures, often get stuck here and declare AI is not ready. If you're in that space, I'll invite you to relook at this. This means you have to use brownfield techniques to make this ready. It might not be simple. It might be very custom to your organization. That's where the creative way of, I like the way Suraj was tried to solve the problem of testing on NFR, right? That level of creative implementation is required to solve this problem. It's not a simple problem, but it is solvable. Once you solve this, then your agentic architecture foundation is ready. Right. So I want to leave you with this question. Is your team using AI fully? With that thought, I think lunch should be ready. Okay, thank you, everyone. I might take 1 or 2 questions, then we can hit the lunch.
Yeah, so in this AI-driven things, like context is the main thing, right? Like it's the core of the entire cycle.
Correct.
So how do you make sure the context is having high quality? I mean, what it's supposed to do. So this context is about doing this. How do we make sure that, because in code you have all unit tests, integration tests, and end-to-end tests. But for contest, how do you maintain the same quality as you iterate going forward, right?
Well, I think that's a question spot on. And that has become the biggest puzzle for all engineers and architects right now. There are techniques. I do not have a magic bullet, one answer to it, but I can tell you the direction. It can be only done by agents, not humans. So if you want to make your context updated, context up to a quality, you write agents and define the quality inside the agents, right? A simple example is what is the structure of a context? More detail is what are the hooks where the context should be updated? A pre-commit hook or post-commit hook or a test failure hook or new test is added, all this, right? So your context designing is the key. My recommendation is put a constraint. It can be only done through agents because that builds the agentic framework. And then let the agents refine. So at some point, you will have agents refining the agents. You get my point? Your test infrastructure is a bunch of agents, which is refining the agents, which is updating your context. Let's say a spec update agent, right? You send a message in a Slack, the message goes to a spec update agent, it takes that, it updates the spec, not the human. Now, the spec update agent itself can learn from many such updates and then update itself. So this is the agentic architecture. So the first level is have an agent update the context. Second level is agent refine the agent which is updating the context. This one? Yeah, see what, correct. So what I've seen is if you're very much using Anthropic and all that, it's pretty simple because Anthropic Teams edition, they give you this metrics. But if you're using multi-models, that's how mostly enterprise will set it up, right? They don't want to tie up with one model. If you're using multi-model setup, most companies use kilo code, open code, or any of these solutions, where these IDs itself track this metric, which can be pulled later into a central dashboard. Yeah, most of them can give you a data, not 100% accurate, but good signal. Yeah, at least I have seen, or I will recommend using kilocode or one of those open source IDs where they do for every PR, they give you this report of what is the AI contribution, what is the human contribution. I think token generated and accepted tokens. Kilo code is it is a plugin on VS Code, which allows you to select up to 500 different models based on your work. So obviously, when you go to agentic, you will define your agentic working. Mostly plan will happen on this Opus and the latest models, reasoning models. But code generation, which is once you have a good plan, that can be delegated to these Chinese models, Qwen, KLM, and so on. Thereby you do what we call usage engineering, where you reduce the token usage. But for small companies, that's not a problem. Enterprise level, you have 1,000 people using 1,000 IDs and consuming token, it might be a budget problem. So there is a usage engineering level. So you need to We also track how much tokens got generated with reasoning models, how much token got generated with generative model, like code generating models, and so on. So you can always tweak the budget and improve on that. So right now it's all manual scripts. Your, for example, lead time, how many times the code review happened is a signal of you not AI slopping. If AI generation code is very good, human review comments will be less. So you can baseline the existing one and then average out with the new comments. If the comments increases, it's a AI slop. If the comment decreases deterministically, that's a AI is working well. Right now, there are some tools. I usually prefer writing your own internal tools, and writing internal tools as a market has shifted because I built the workflow feature for apps, which is a low-code solution for enterprise. Now, I can tell you the low-code solution market itself an identity crisis because anybody can write internal tools with agents, with LLM. So whatever metric you want to track, you are just 3 or 4 prompts away from having that script ready, and then pushing into your traceability observability stack. So you write your custom script is what I'll encourage. Don't look for SaaS tools or any custom tools.
Okay, we'll go to the last question from Suraj.
Yeah, great talk. So I learned a lot of cool things from this. One important metric, right? So you mentioned that how do we ensure that the teams are just not writing code, but the code is having some sort of value associated to that code, right? Yeah, so it just got me thinking that how can we make this more meta? And by meta, what I mean is that how can we ensure that it finally ties to your internal business metrics, right? Now, business metrics is obviously like the most important is going to be your top line, bottom line, right? Or some kind of proxy to it. Let's say your number of users, usage rate, and all these things, right? How do we ensure that we tie up actual code to your final business outcomes so that we don't really need to track, right? Like if like a team is actually generating 100 PRs, right? Now that 100 PR might be a good metric, but then is it actually useful and value adding to the business, right? How do we ensure we plug that final, that missing piece wherein can your code tie to your business metrics? So as long as you're making money, well and good, right? You write any amount of code, right? Do you have any thoughts on? Thank you.
That's an amazing point. I will not claim I have thought through that deeply, but that is an amazing point. I think with the foundations, the rest of the foundations ready, I think that will be the next obvious questions which opens up, which was not usually a point of discussion in the previous way of building. But yeah, that's an amazing question. I would like to think a little more on that. I do not have a ready-made answer.
Thanks, Rix, being open that every question can bring another thought process. Okay, I will now invite Dinesh to a thank note for the speakers. Goodies. Yeah, Shrix, please be there. So Myntra is, yeah, 1H, I think. And Suraj and your partner. Yeah, you can stand centrally just. Yeah, there's a photographer taking photo, but please smile. All volunteers of LSP. Okay. So I'm terming photographer. That's not an insult to Sri. Okay. Just go ahead. Those two. Thank you, Dinesh. Thanks for hosting us and supporting the community. Thank you. Okay. So now we'll break for lunch. Important information is, we'll show it in the board actually. So there will be further questions. Okay, and the speakers are liable to answer those. Liable in the sense we make them liable to answer. Okay, we make them join our Discord channels. So there's a dedicated channel for 58th event. So you can ask your further questions, and we are requesting speakers to share their deck as well so that we have continuity. Okay, we use the Discord channel for future meetups, talk proposals, talk ideas and all. Please join the Discord channel and be collaborate. Okay, thank you. Let's break for lunch. to fill, and staying connected is most important. This community is alive because some of us worked in an organization who had human value at the top, and all of us who were colleagues then uh, become very good friends, our family friends, and all those stuff. So we are still very close, and that's the core of keeping this community alive. So it's an important part. Being an engineer, you will have to run very long in your career because you are a knowledge employee, and there is as such no such retirement for employees who are selling their knowledge. Okay, so to keep alive some sort of initial gyan so that you are awake. Okay, Arkadeep, back to you. But you are sitting and staying, then I'm 100% sure you will do. Now, okay?
हेलो ये पहनेगा हेलो
हेलो बोलने के लिए बोला है. हेलो, am I audible?
हेलो हेलो हेलो
Great. Hello, hello. शेयर तो किया है. Okay, fine. Okay, I have any remote. Come back. Hi guys, good afternoon. After lunch, pretty difficult to talk. So my talk is about BBQ. What do you understand about BBQ? What comes to your mind? Barbecue, perfect. So we are going to talk about barbecue, but with a twist. So it's about the better binary quantization. And why we are using that? For improving the infrastructure inference. What is inference? How could we train our model better? How could the model give us a better result? And not only that, how fast it can give. So with that, let's get started. I will use some memes. So just a disclaimer that all the knowledge is available on the public. No company confidential information is being shared. Okay, so a few questions. How many bits are in 1 byte? Very good, right answer. Super. Great. How many bytes in one float 32 vector? Very good, correct answer. So for byte, that means 32 bit. Now you can use your mobile calculator, anything. How does a float 32 image 1920 cross 1080 pixel? I was trying with some different dimension, but I saw that this is a very basic 2.7 megapixel camera actually captures this. So how much will be the raw size? Any guess? You can use your calculator, Google. Anything accepted. Yeah, couple of mobiles in action. Come on. Do calculation, no Google of this same question. Okay, question for the newcomers for coming late. How much byte a float 32 image have providing this pixel? Okay, fine, let's come back to the answer. So, okay, shant ho jao. Fine, so if we calculate that the pixel into 4 byte, so it is coming as 82 lakh 94,000 bytes. And if I call it as a color image, pass it through a RGB channel, then multiply it by 3. Aram se ja. करने दो ना. So that coming as 24.8, which is 25 megabytes for a normal basic image. And think that these people are clicking photo, how much will be the size? Oh, acha. I'm coming. Fine. So not only that. So say for example, whenever we save normal image like this, then we also save multiple parameters which can be tweaked for image processing, for enhancing the image. And also any image we have also stored the metadata like the camera lens, who clicked, when clicked, multiple data. So more number of channels are used. So at the end of the day, data volume is going to get increased. Everyone is with me till now? Perfect. Now, after lunch, let's watch some 2 videos. First video. Oh, I have to tweak a bit. 1 second.
Finishes off in style. A magnificent strike into the crowd. India lift the World Cup after 28 years. The parties start in the dressing room, and it's an Indian captain who's been absolutely magnificent in the night of the final.
Watch the second video and then I will ask.
Woo! Woo!
So tell me about the similarities between these 2 videos. Maybe I will take 5 different answers. More is okay. Cricket, okay, right? India, what India? World Cup, very good. Louder, it's okay. Winner, right? World Cup champion. Anything? ICC logo, yeah, correct. More heavy. Fine. So, fine. Yeah, so this is just to set the context. So fine. Couple of things. You all pointed correctly. It is about the cricket match, India winning the World Cup. But a couple of things we have not talked about. This is T20 World Cup. Sorry, this one is the T20 World Cup. This is ODI World Cup. This is a winning shot and this is the prize celebration. But we as human come back to the direct point that this is the Cricket World Cup, India is winning. So that means a lot of amount of data, but we, as a human, have the tendency to summarize the part and keep the only relevant. Because at the end of the day, whether it's our memory, our brain, processor, everything have its own limitation. So anything or everything, whether me, you, or a system does, whether we generate, create, do, or process, at the end of the day, it leaves a footprint as data. And where the data is saved? Correct. Now, think of a scenario that we have just done a calculation that about the one basic image, how much size it takes. So how are you going to save that? What are your thoughts? Very good, compress, anything? Remove duplicates, okay. Anything? Very good, what does that call? Quantization. You are right, absolutely. So there are two types. One is that compression, another one is that the gentleman told quantization. Let's have the difference between these two. Let's like to go first. That it's about that we have a bigger image we are trying to save with the everything we are trying to compress. So I hope that people in the last can read it. Great, okay. So if we can encode the information in a fewer bits than the original, we are compressing. So it's about the overall compression. Why we do that? To save disk space. But why we do the quantization? It's about that we can map the relevant information. Only the critical information need to go to the ML infrastructure. I don't need about the everything like that, who clicked the photo, when clicked the photo, but most important thing. Few applications, I think that you can go through, so it's kind of a reducing the storage footprint, and here it is about the increasing the computational speed. And here, most important thing that Huffman coding is being used in the compression, but in the quantization, we have multiple methods, but I will talk about the BBQ method in some time. And the application of this is that deep learning, computer vision, like that. So let's talk about the quantization. As we know that it's about the making it lossy. How are we talking it about lossy? So it's reducing the precision. So consider that this is my object on my your left side. We are taking one pixel and then calculating what are the important feature of that. Then creating a map. And after that, we are superimposing or remodeling again so that we can get a better picture. So of course, whatever the original and whatever the generated image are not the same, but at the same time, we have that solution today. Everybody have that, so that from this image, we can understand what is that, and also machine can do that. And we can also recreate the original image. So few applications: signal processing, image and video compression, machine learning. And what are the benefits? Of course, it reduced storage, improve the computational efficiency, and we could do the faster inference. So talking about the quantization, so whenever we do, we generally consider a couple of things, that what is the first percentile, 50th percentile, 90th percentile, and upper and lower bound. So if we keep this image as a normal quantization, so this graph look like this. But I will come back very soon about the better binary quantization. And if we implement this technique, we reduce that, whatever the decimal pointer we have created, we will reduce that to some significant amount, and we will have the up to 8x reduction size. I will reduce further, 32x is my goal. What will happen? If you can see that if you just zoom in, this picture will look similar. Now here we have not much loss, but it will help you in the faster search and perfect for Lucene, which is the elastic search engine. Let's take one more thing. Consider that this is some satellite and this is some nebula. If I need to superimpose your right side image to the first image, what all technical terminology you can use? So it's all we do in the GPT, I mean the generative image. So we tell that, hey, superimpose this image over that. Mask, okay, fine. Layering, correct? Anything? Okay, fine. Let's talk it this way. What are the technical thing that we need to do. Think about the linear algebra standpoint. Correct, absolutely. Multiplication of the two metrics. So consider that we have something that if we are going to, I'm just taking some random example, that 8 is represented as the binary, this value, 15 is represented that value, 9 is this value. And if we do the calculation, then this is my final value and that represents this. So just think about the number, that how much calculation is happening whenever you are trying to superimpose one over another or probably trying to generate something new. Let's talk about the challenges in the modern vector search. So this is about the computer architecture. First, you have the CPU. Any idea about that? How much is the CPU size, speed, anything, or probably price also? Okay, right? 10 CTE, okay. And we agree that CPU is the costlier one among all these. Top, correct, very good. Now we have the register. Register comes with the CPU, so we can combine this together. And now we have the cache, which is the L1, L2, L3 cache. This is comparatively slower. So I have the taken a comparison that, say, for example, from L1 or L3 cache, I have done that. So from L3 cache, if I need to retrieve the data to my processing for inference, it generally takes 5 seconds. Now comes the memory, which is your RAM. From RAM, it takes generally 52 seconds. That's a significant. Coming back, this is the non-volatile memory, the latest hard drive available in the market. It takes 2.5 minutes. And we have the Gen 3, which is double. The set, okay, fine, you cannot see. Okay, fine, I can see that. Good. So we have the SATA HDD, which takes approx 2000 seconds. And if we use the traditional HDD, what we started with in our life as our home computer, that takes around 6000 seconds for processing any image. So understand about the latency part, that how much time it takes to traverse from there to my machine learning model. Now we will talk about the better binary quantization. What is the idea? That it's a lossy compression technique and it converts things into zeros and one, but with a twist. How? Say, for example, if I give you some number that 105, 110, 160, 190, can you tell me that what will be the median of that? All the numbers are above 100. Between 100 to 200, what will be my median? Louder. No, 130. 20. No, all numbers are above 100. 120. Okay, fine. Any other guesses? So repeating one more time, my numbers are discrete numbers between 100 and 200. Anything you tell. One guy told 120, 150. Okay. So we are keeping, yeah, that's actually the correct answer. So we are keeping something in between. By that we can do. What the quantization does is that whatever the number you put, it compares from the zero, like the sea level. And if it is above, put 1. If it is below, put 0. But here we talk about the better binary quantization. So we calculate the median from the available data set. We don't consider the benchmark. So by that, we are creating, instead of converting into 0 and 1, from the median, from the 0 standpoint, we are calculating the median, and by that we are just making that. So what happens here, that it helps us to get much accurate information, that what are the standard deviation and other things. We have the median, so from there we can calculate. And yeah. Yeah, so here we are also using a greedy algorithm. So what greedy algorithm does, anyone can tell me from the reinforcement learning, anything is okay. What does the greedy algorithm does? So it actually explored further. Instead of knowing that I know this, I will only come back to this. No, I will explore whatever the data point I get. So it actually scraps all the data, and based on that, it finds that what could be my median. And as a result, it processes the significant amount of data. So the compression Of course, we also get the compression error, but we preserve that and we use the approximate nearest neighbor function so that we can construct the error value and then resolve that. Fine. So this is while I was creating the presentation. So I searched this. What is the ideal memory to storage ratio for better performance? Do you know what Google gave me the answer? This all data are kind of collected from different source. Google told that nothing like that. Wrong question. Actually, if you can search it, you will get like that. But I deep dive and then find that if you, from the point of view of the Elasticsearch, that if my hard disk size is approx 30, then I should use 1. So 30 GB is to 1 GB is the recommended size in order to process. And you know what is the size of our RAM and storage these days. Whenever we are doing a GPU training, it is kind of a 3:2 or 2:1 between the RAM is to memory for a better performance. So I just think about the in terms of the hardware requirement. And now talking about the impact. So one image I am trying to process through the machine learning that, hi, what is about the training, and after that I will do the inference. So think about that how much size it takes. So the blue line is that if I take as a float, if I take as int 8, if I take it as a vector, that int 4, and if I take the vector as the BBQ, then the size reduction. Talking about the different dimension, I have also done the comparison. Based on that, you can see that this actually making that median part, what we just discussed, if we can calculate that and compare accordingly, then it gives us a much better result. Can you guys see what is that? What is the color? Yeah, tell, no wrong answer, no punishment. What is the color? Red. It's actually white and black. Why many of us told red? Because already this image has been implanted on our mind that Coca-Cola is red always, but it's actually black and white. I can see clearly, but this image is available over the internet. So by that, I mean that already some information already implanted. So say, for example, you don't need to train the machine multiple times. Hey, this is that, this is that. It already knows few things. Just check that, reuse that. Coming to one more video. This video was not playing while I was sitting there. Okay, fine. Have a look, I will ask question. Intentionally muted the sound. Tell me what happened. Whoever have not answered so far. Yes, tell. Moon landing, okay, fine. Soft landing, correct? Coming down, right? So, correct, everyone is correct here. So what I want to, okay, so it is continuously playing, okay, let it play. So the thing is that it actually landed in moon, but we recreated the image with some animation. It was an animated video. But we considered that it was a moon landing, and based on the parameter, we could understand. So again, reiterating, I will now jump into the technical. That was the last video on my slide. So the point was that whatever your image is, or whatever your video is a frame of images. So whatever you pass it, that it also a huge amount of data, but if you can represent, the system will understand. Fine. So talking about the vector search, one of the very critical information is the hierarchical navigable small world. Anybody like to talk about this from the vector search standpoint? Already things are written, but anyone wanted to share something that why it is used? Yeah, please. For cross-document analysis? Yeah, correct. Anything? Similarity search, vector search? In between. nearest neighbor, right? So just giving a summary that we have used for the vector search. So say, for example, if I talk about orange, the e-commerce site generally also shows me about the other fruits like grapes and all. So it's about the similarity, understand the context and show me the relevant data. So this is one of the best practice in the vector search, hierarchical navigable. Whoever are not known, please read about it. It's very interesting. Now I will come to the better binary quantization versus HNSW comparison. So few advantage we have here that it's BBQ actually, if you remember my previous slides, that it actually compress the disk space. So whatever the new training you are making, it is making faster. Whereas for the HNSW, it generally works with the text data. For image, there was nothing as such in the market. But when we talk about the BBQ, so it already stored into the disk, and considering that it's a less storage, we can save larger quantity of the images, and it also a memory efficient because as your size gets reduced, your time network latency gets also reduced. You could infer it faster. So your query performance improves. So few things that when to choose what. So whenever you have a large disk-based data set, BBQ is a better approach. Whenever you have a dynamic data, so you don't have a static data continuously, say, for example, streaming from IPL. So you have a continuous data coming in. So in such cases, BBQ will help a lot because all your new data are coming into the pipeline. Any question, yeah, please? Okay. Correct. That's correct. But so far, in terms of the BBQ, what we have done is that we have already quantized. So HNSW can be applied and it is already applied. It's a quantization mechanism. Yes, you can. Absolutely, you are right. So again, these are not to the competitors. These are the two different approaches. How, if we need to compare, then how can the comparison be done? But of course, you can integrate these two together. Correct. Again, very good question that in such cases, BBQ is not the right fit. So I had also, so when I, no, not for similarity search. Correct. It's for the training and the inference. Yeah, you can do. Huh. Correct. Happens. Yes. Correct. Size. Two. No, not the whole idea, but some part. I will. Huh, correct. Okay, any questions so far, or may I proceed? Okay, great. Fine. So how it helps that infrastructure saving as a scale. So say, for example, if I need to find a 100 million vectors with 384 dimensions, which is huge. A raw float 32 will generally take 143 GB. If I use the int8 scalar, it will take 36. But if we use the BBQ method, what this gentleman already explained, that if we, instead of floating point, if we could compress based on whatever we just discussed, I'll be free to repeat that. But at the same time, if we use that, look into the significant reduction of the size that is required. So, okay, so it is 32x faster than the quantization, and it also leverage. So we have the API, in the Elasticsearch, there is also API. You can program with the Python, many languages. So with that, you can actually program it accordingly so that your manual intervention time also gets reduced. As a result, your query latency less, inference time is faster. Let's see some example. Again, public internet example from GitHub, that here we are calling that enterprise better binary quantitation index answer for you, answer for you. We are also using the BBQ underscore HNSW, so we can combine together as per our index. Now, whenever we are posting that, here we are posting that what is the nearest neighbor. Here I am taking 10, you can choose as per your requirement and whatever the things. So based on that, we can do the rescoring, and that will give you the clear idea that how much result, I mean, how much accurate will be a result. Correct, correct, yes. That can be calculated, that we are not storing. If you get that, say for example, just think about the standard deviation formula, we can calculate it. So we are not storing into the disk, let machine do that work. Each set of vectors, not individually, but set of vectors for the set. Correct, correct. Okay, so let's talk about that. How could we implement and how could we benefit from that? So earlier, if we say, for example, for the limitation of the storage, limitation of the our hardware resource, we used to try with the small models. But if we could implement the better binary quantization, then we could use the larger model and it could give us a better results. Think about the billion parameter model that we have. So the more number of billion parameter it have, the better it infers, better it gives the correct result. What will be? It will be improved than the traditional one. Quality, you know, so the already the benchmark is there. So I cannot share few data, but whatever I could share, info better mode. So already, yeah, correct. So again, in case if we, even if we don't use the better model, even if we try with the small model also, at the same time we will get the better result because we are passing the same, because model we are not touching anything. We are on. That was the quantization. That was quantization, basic quantization, not the better one. And few checklist and the use case. So far, whatever the benchmark index has been found that BBQ is optimized for 384 dimensions. More, of course, industry, if you think about the aerospace industry or the media industry, it generates more dimension than that. But as of now, it is not capable based on Elastic version 8.2. And centroids update incrementally, as you said, told that whenever we are serving a new data set, we have to get the centroid. And if we change the data set or probably the centroid, some data in my set has changed, then I have to update that also. And that is called as segment merging. And of course, it basic minimum requirement is 4 GB RAM. That I believe that even our mobile phone has that. Am I right? So one more thing is called as acorn. So what is that? I'm not probably this needs a total different session to discuss about the acorn. I have some articles in upcoming slides, but in a summary, that is a graph-based indexing. So it's similar to HNSW, but not similar, not the same, which is a graph-based indexing to optimize the similarity search. So again, this acorn and BBQ works together to give you a better inference result. And this helps to the higher search performance and accuracy. So here, if we talk about the text data like the LLM, so here it helps if you use the acorn, it will also give you the better data, better result and faster data. So just recollecting and final thoughts. Do you remember what was that? Already answer is written below. So this is the first ever human imprint to measure. So first data, that is the 3 marks. And today we have came up to this. And tomorrow, already NVM we spoke about that from the hard disk, SSD and NVM. So data size, we are also increasing. At the same time, you know how much EI is exploding. But at the same time, we have to think about the latency, how much time it takes between my model training and model inference. Because you know that in this era of probably real, we are very much impatient. So if my model does not give result on time, we will lose focus and probably will not use it further. So think about the speed, network speed, performance as one of your important benchmark. With that thought, I like to take a break. And here are my reference materials. So few couple of things from the Elastic. And based on one Elastic invite, I had wrote one Elastic blog about how could we use that. So couple of reference article I had generated while I was compiling all this. And there was one YouTube video by one of the principal engineer from Elastic. And this is some GitHub example. And this is how the inference all about. So this is me. Thank you for your time and being an awesome audience. Thank you, Myntra, for giving me the opportunity to speak here. And that's pretty much. I will be open for any questions here. Yeah, please.
Okay.
So there was one mention about better ranking that you would achieve with BBQ. Can you explain why we would get better ranking compared to other search algorithms overall?
So think about the large language model that whenever we are doing that, so if you could infer it better and probably for the share, for small size of data, you could pass more number of training data to your model. Model is up to you. I'm not commenting anything about the model. So if your model is better and you provide much number of data, so then law of average comes and your response is better. That's the general thoughts. I have time. Otherwise, Devanshu will stop.
Say a bit more about the graph, elastic econ that you are talking at the end, and maybe small comparison with BBQ, how different.
It is not the comparison. So BBQ, the Q stands for quantization, but econ, there is no acronym for that. It is for the graph. Let's come back. Yeah, so it is about the graph-based indexing algorithm. So totally different, but say for example, as the product upgrades, then it releases new features. So in the 8.2, that was a new feature. And when I was researching about the BBQ part, Econ was one of the important thing. That's why I thought to include as a just a footer that this is one of the important thing that can be considered and can give you a better result. Yes, please. Mike, otherwise no question.
Is BBQ exclusively used for Elasticsearch or we can use for other models which are open source?
As of now, Elasticsearch have that product, so they have patented it. And
what would be like a best example for the implementation?
louder, please.
Yeah, what would be the best example for this implementation? Like OLLM model, OLLM something application is there, right? So we can use in the local laptop. We don't require that much of process, right?
Correct. So talking about the language model, LLM is the language model. So already your text are kind of a very small in size. If you remember the calculation I started initially, that 1920 into something. Say for example, this laptop, very simple one, that is approx 3500 into 2368, I believe, the resolution. So if I have that much bigger image, then my data size is going to be high and all the things that I told. But if we use the compression, then I can, as I was answering to that lady, that if I can provide much number of training images, then it will help me for better training. But for the language model, it will be over it. Already there are models which are capable enough to do that. But of course, you can use that with the BBQ, provided probably you are training on a very significant amount of information which are not suitable in that case. Yeah, please.
Hello. Yes. So do you have any benchmarks that show these performance, precision, and recall plus the sizes on?
Yes, benchmark is there on the website. I have not included that because few things just I called 95% performance improvement and 32x space reduction.
Compared with just NHSW without quantization?
There are comparison, but I have not included. Say, for example, if you are taking the image that we have already discussed, and we have also talked about the text-based images. But what are the other type of? Of course, audio can be one of the thing which is coming in. Oh yeah, I got your question. Fine. A very good question that when all we are going to use and when all not to use, which is the most important question. So if your data size is too much, then use BBQ. But if your data size is not significant and you are capable enough to other models, other infrastructure, I mean, other, what I would say, vector search model can do that, then don't use it. Seriously, it will be overhead. Does that answer? Okay. Yeah, please.
So you mentioned elastic econ is for dense vector data. If we have skewed vector data, can we still use BBQ?
Repeat the question one more, please.
So let's assume that our current data, the vector data is a little skewed. A lot of values are on the higher side, let's assume. Do we need any pre-processing before we use BBQ?
Correct, I will answer that. Say for example, that why you are calling it as skewed, because you are comparing from a benchmark, you find the median and then you find that some data is on the probably left side or right side. But whenever the BBQ is being done, I remember that I told that few things machine can compute. We are not storing, let the machine compute so that our disk space gets saved. So in that term, think about that if it is skewed, already machine calculated the new median. And based on that, it rebalance both side equilibrium. Does that answer? Great. Thank you for wonderful audience. Okay, bye. This slide will be available in my website, but I don't want to promote that much. Okay, over.
Thanks, Orkodip. Actually, the way he started was all helpful to keep everybody awake. So I was impressed the way he chosen the videos to bring the comparison to the table. It's a nice talk, actually, pretty. We liked it. I think the number of questions that we had during the talk as well as post the talk. So I would like to invite Nachiket to give the goodie to Orkodip on behalf of Myntra. Photo can, Sai. Somebody can take the photo, please. The camera is there. Just give 1 second. Okay, what you were trying to do? Okay, sensitive. Okay. Thank you very much, Arkadev. Thank you. Thanks a lot. Okay, so we have one QR code to be presented, not for feedback. This is to join our Discord group. We created a QR code right now. So just wait for a few minutes, look at that, get into the Discord, and then we will get to a group photo, and that should be all end of the session. You're gonna grab a cup of tea, network, and then leave for the weekend with lots of thought. Thank you very much for being with us on a Saturday. On a busy life schedule, coming on a Saturday is not easy. I know everybody needs to put a lot of effort to do that, and that too for learning, not to do a party. So it's a big deal. Thank you very much. We'll take a group photo now.